Hello everyone, so today I'll be discussing question number 12 of GATE 2014 set 1. In a beam of length L, 4 possible influence line diagrams for shear force at a section located at L by 4 from the left end support marked as PQRS are shown below. So these are 4 possible influence line diagram for shear force at a distance L by 4. So the correct influence line diagram is, so 4 options are given to us and we need to find the correct influence line diagrams of all these 4 options. It's a 1 mark question. For this type of problems you can refer to lecture series on structural analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. So to draw the influence line diagrams quickly, I'll recommend you to use the Muller-Breslau principle. So that will be very helpful during the GATE exam. So let's see how to draw the influence line diagram using Muller-Breslau principle. Although for this particular problem, they only asked us to find the ILD for shear force, but I'll discuss here how to make ILD for reaction, for shear force, and as well as for the bending moment for a statically determinate beam. Please note that ILD for statically indeterminate beams are little bit different from this determinate beams, so I'll discuss only determinate beams here. So suppose we need to find the ILD for reaction using the Muller-Breslau principle. So for finding out the ILD for reaction, we will follow the some steps. The first step is, suppose we need to find the ILD for reaction at A. So the first step will be to remove the support and apply displacement at the support location. So we will remove the support A if you want to draw the ILD for reaction at A, and we will apply unit displacement at this support. So if we apply the unit displacement at this support, let's call it, we have moved the point A to this point, so the deflected shape will look like this, right? So the deflected shape will be the ILD for reaction at A. So this will be the ILD for reaction at A. Okay, we can follow the same steps if you want to draw the ILD for reaction at B as well. Let's discuss how to find the ILD for shear force. To find the ILD for shear force, let's consider the simply supported beam. Let's say we need to find the ILD for shear force at point C. So we can take distance as 2.5 meter, this as 7.5 meter. The first step here will be release the shear at that particular point by introducing a slider. So if we want to find the ILD for shear force at C, so we will introduce a slider here. The second step will be apply unit displacement as shown. So for that we will apply the unit displacement like this. We will move the right part upward and left part downward. After applying this displacement, whatever will be the deflected shape of this particular beam will be the ILD for shear force at C. Please note that the total displacement should be 1. Okay, so let's draw the deflected shape after introducing this slider and displacing the beam like this. So the deflected shape will be like this, right? So this will be the ILD for shear force at point C. So since this total displacement has to be 1, so let's say it is x here, so it will be 1 minus x. We can easily find out the value of x from the similarity of triangles. So we will consider this triangle 1 and 2. Let's consider triangle 2. So it will be x divided by this length. This length is 7.5, should be equal to 1 minus x divided by this length. This length is 2.5. Okay, from here we can get the value of x minus 3x. It will be 4x equal to 3. From here we will get the value of x as 3 by 4. Okay, so we can get the value of x and 1 minus x from here. Now let's find out the ILD for bending moment at any point. Again, consider this simply supported beam. Let's call it A, B and C. Suppose we need to find the ILD for bending moment at point C. Here also we will follow two simple steps. Step 1 is release the moment at that particular point by introducing an internal hinge. So since we need to find the ILD for bending moment at point C, so we will introduce a internal hinge here. The second step is apply unit change in direction at that particular point. So here also we will apply the unit rotation in some specific direction. So like this, we will apply the unit rotation like this. Please note that total rotation has to be 1. If we apply the unit rotation like this, the beam will deflect. So deflected shape will be equal to ILD for bending moment at C. For this case, the deflected shape will be like this. This is the ILD for bending moment at point C. Here, this is rotation. Let's call this rotation as theta 1 and this rotation as theta 2. So total rotation should be 1. So theta 1 plus theta 2 should be equal to 1 here. We can easily find the value of theta. So theta 2 can be written as, let's call this distance as x. So x divided by 5. Theta 1 will be equal to x, this is also x, so theta 1 will be equal to x divided by 5, and theta 2 will also be equal to x divided by this distance 5. Since theta 1 and theta 2 are very small, so we can write it like this, equal to 1. From here we get the value of 2x by 5 equal to 1, and x is equals to 2.5. So we can get the value of x here like this. So now we have seen how to find the value of ILD for shear force, reaction and bending moment. Now let's come back to our question. Here we are given one beam, so it will be a simply supported beam, and we have to find the ILD for shear force at distance L by 4. So let's draw one simply supported beam here. And let's this point C be at L by 4 distance. So this distance is L by 4. So again we will use the Muller-Breslau principle here. So the Muller-Breslau principle says that we have to follow two basic steps. The first step is introducing a slider at that particular point. So I'll introduce a slider here at, let's call it as C point. I'll introduce a slider here. The second step is to apply the displacement like this, the right part upward, the left part downward. So whatever is the deflected shape will be the ILD for shear force at C. So if I'll deflect this beam like this, so ILD will be like this. We'll join everything. So this will be the ILD for shear force at C. Now let's find the value of this x and 1 minus x also. So again like that we will use a similarity of triangles for this. So x divided by 3L by 4 equal to 1 minus x divided by L by 4. Again it is 3 times, so x equal to 3 minus 3x. From here we get the value of 4x as 3 by 4. So we get the value of x as 3 by 4, and 1 minus x will be 1 by 4. Let's check the answer. So this is similar to option, this P diagram, right? So the correct answer will be option A.